This video is brought to you by mywayteaching.com.
Let us consider a simple problem in this part. The problem is the position of a particle is given by r is equal to 3t I cap plus 2t square j cap plus 5k cap, where t is in seconds and the coefficients have the proper units for r to be in meters. So in this we have to find we have v of t and a of t of the particle in the first part, and then we have to find the magnitude and direction of v of t at the time t is equal to 1 second. So first, to find v of t, we have that equation that is given by dr by dt. So the position vector is already given in the question, isn't it? So by substituting that position vector in the place of r, we can get the value of v of t. So this is the value of v of t. Okay. Now let us find the value of a of t. We can find the value of a of t by dv by dt. So we know the value of v, isn't it? Just now we found. So if you differentiate it again, we'll get it 4.0 j cap, which is nothing but the value of a of t. So now a is how much? A is 4 meter per second along y direction, isn't it? And its magnitude is given by now we should find the magnitude of v of t at t is equal to 1 second, isn't it? So the magnitude of v can be found out by using this value of v, that is 3.0 into I into 4.0 j. So we have to substitute the value of t as 1 second. So we get t is equal to 3.0 I cap plus 4.0 j cap, and its magnitude is given by square root of 3 square plus 4 square, that is given by 5 meter per second, and the direction theta is given by tan inverse of 4 by 3, that is Vy by Vx. Okay, so it is 53 degree with x-axis. Now let us study motion in a plane with constant acceleration. Suppose an object is moving in xy plane and its acceleration a is constant. Over an interval of time, the average acceleration will equal this constant value. Now, let the velocity of the object be v naught at the time t is equal to 0 and v at the time t. Okay, then we can write the acceleration as v minus v naught divided by t minus 0. If you want to write it in terms of components, we can write Vx as V naught of x plus Ax into t and Vy V naught of y plus Ay into t. So now let us find the position r that changes with time. So here we follow the method that we used in one-dimensional case. So like let r0 and r be the position vectors of the particle at the time 0 and at the time t. And let the velocities at these instants be v0 and v. So then over this time interval t, the average velocity, that is nothing but v0 plus v by 2, isn't it? So the displacement is the average velocity multiplied by the time interval. So the displacement over this interval is given by r minus r0, that is nothing but average velocity multiplied with the time interval. So V can be represented as V0 plus AT, isn't it? We already learned this. And if you simplify this, we get the position vector value okay. So the value of R we can get R0 V0 into T plus half AT square. It can be easily verified that the derivative of this position vector, okay, that is dr by dt, gives the value of acceleration a, okay, that is v minus v naught by t. And it also satisfies the condition that at t is equal to 0, r is equal to r naught. So if you want to write this position vector equation in terms of component, so we can write it as x is equal to x naught plus v naught into x plus half ax into t square, y is equal to y naught plus v naught y, here we should add t, this is also t, plus half ay into t square. Okay, so motion in a plane can be treated as two separate simultaneous one-dimensional motions with constant acceleration along two perpendicular directions. Okay, after seeing this equation, one thing is clear, that motion in a plane, it can be treated as two separate simultaneous one dimensional motions with constant acceleration along two perpendicular direction. Okay, so now let us solve a simple problem on this. The problem is, a particle starts from origin at t is equal to 0 with a velocity 5 meter per second and moves in xy plane under the action of a force which produces a constant acceleration of 3 into I plus 2j meter per second square. So first we should find what is the y coordinate of the particle at the instant its x coordinate is 84 meter. What is the speed of the particle at this time? So to find the y coordinate, which means it's related to position. So the position vector of the particle is given by isn't it? This is the position vector. And they have given the value of v naught, that is 5 I cap. Okay, and they have given the value of a. So we can substitute both of these values in this particular equation. So from this we can get the coordinates x of t as 5t plus 1.5t square and y of t as 1.t square. Okay, so we know the x of t, that is given as 84 meter. So we can find the time t using that, isn't it? So let us find. X of t is given by 5t plus 1.5 t square, isn't it? So x of t is given as 84. So if you simplify this, we'll get the value of t as 6 seconds. So at 6 seconds, the value of y of t is given by t square, that is 36 meter. Okay, so we got the value of x of t and y of t, isn't it? So we can represent the velocity v as dr by dt. Okay, so the position vector, we know the value of position vector. So if you differentiate that position vector, we get 5.0 plus 3t into I cap plus 2t into j cap. So at t is equal to 6 seconds, the velocity is given by 23 I cap plus 12 j cap. So if you want to find the magnitude, we should take the square root of 23 square plus 12 square, that is given by 26 meter per second.